June 12, 1942, Willow Run, Michigan. As the morning fog lifted over the vast expanse of Ford's new bomber plant, Dr. Friedrich Hoffmann adjusted his wire-rimmed glasses and scoffed at the sprawling, unrefined factory complex before him. The German aeronautical engineer, now a reluctant guest of the United States government, following his capture in North Africa, was certain this American experiment in mass production would prove to be yet another example of quantity over quality, brute industrial force lacking German precision and ingenuity. Little did he know that what he would witness in the coming months would fundamentally shatter not only his professional convictions, but the very foundations of his worldview. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how America's unprecedented industrial might became the most effective psychological weapon against the Third Reich's technical elite. Dr. Friedrich Hoffmann had been one of Germany's most celebrated aeronautical engineers. His work on the Messerschmitt Bf 109 fighter had earned him the personal commendation of Hermann Göring and a position of respect within the Luftwaffe's technical division. His capture during an inspection tour in North Africa had been an embarrassment to the Reich, but for American intelligence it represented an opportunity. Rather than sending this prize to a standard POW camp, the War Department had arranged something special. Hoffmann would be embedded at Ford's Willow Run facility as part of a classified program to evaluate German reactions to American production methods. "This is to be your new assignment, Dr. Hoffmann," Major William Donovan explained as their military sedan pulled up to the administrative offices. "The United States government believes your expertise might be valuable here." Hoffmann's thin lips curled into a barely concealed smirk. "I doubt I will find much of technical interest in this warehouse," he replied in accented but perfect English, gesturing toward the enormous structure. Major Donovan simply smiled. "You might be surprised, Doctor. The folks here are producing something rather special." The something special was the B-24 Liberator, a four-engine heavy bomber that represented the backbone of the Allied strategic bombing campaign. Designed by Consolidated Aircraft, the B-24 was a complex machine with over 1.5 million parts, 360 Sauser rivets, and dozens of sophisticated systems. Prior to America's entry into the war, producing just one aircraft took approximately 200,000 man-hours and months of skilled labor. "You'll be working alongside Mr. Charles Sorensen, Ford's production director," Major Donovan continued as they were led through security checkpoints. "He'll show you around the facility." Sorensen, a burly man with calloused hands that had risen through Ford's ranks from pattern maker to production chief, greeted them with a firm handshake. "Welcome to Willow Run, Doctor. Ready to see how we build bombers here in Michigan?" Hoffmann nodded curtly, already formulating the technical critique he would mentally catalogue for the day when he would return to Germany. The American's folksy demeanor only reinforced his preconceptions about the crude, unsophisticated nature of what he was about to witness. The first stop on their tour was the massive main assembly building, a structure so large that Hoffmann initially struggled to comprehend its scale. At nearly a mile long and covering 3.5 million square feet, it was the largest single industrial building in the world. "We broke ground just last year," Sorensen explained with undisguised pride. "From farmland to this in about 18 months. "Impressive dimensions," Hoffmann conceded with academic detachment. "But size does not equal efficiency. Our facilities at Messerschmitt are 1/10 this size, yet produce aircraft of superior performance and craftsmanship." Sorensen didn't take the bait. "Well, Doc, we have different objectives. Your fighters are hand-built by master craftsmen. Beautiful machines, no doubt, but we're doing something else entirely here." As they moved deeper into the facility, Hoffman observed the assembly process with increasing curiosity. Unlike the workshop approach he was familiar with in Germany, where highly skilled technicians would build aircraft in essentially stationary positions, Ford had implemented a moving assembly line for bomber production, something considered technically impossible by Luftwaffe production experts. "You're building complex aircraft like automobiles." Hoffman couldn't keep the incredulity from his voice. "That's exactly what we're doing," Sorensen confirmed. "Mr. Ford figured if we could build a car every 60 seconds, we could adapt those principles to bomber production." The German engineer shook his head. "This is fundamentally misguided. Aircraft require precision fitting, individual calibration. Your workers, many of them women I notice, lack the years of technical training necessary for aeronautical construction." Indeed, the workforce was remarkably diverse by German standards. Women made up nearly 40% of the employees, many of whom had never seen an aircraft up close before taking these jobs. African-American workers labored alongside whites in positions that would have been unimaginable in pre-war Detroit. "This is June Lucas." Sorensen introduced a young woman operating a riveting machine with remarkable speed. 6 months ago, she was a housewife, never held a tool in her life. "Pleased to meet you," she said, briefly pausing her work. "I'm making $125 a week now, more than my husband ever made. And sending those Nazi planes down in flames makes it all worthwhile." Hoffman bristled, but maintained his professional composure. "And the quality control? Surely these new workers create significant defect rates?" "Follow me," Sorensen replied, leading him to a quality inspection station where completed wing sections were being methodically checked with gauges and measuring tools. Technical Sergeant Robert Martinez, an Army Air Forces inspector, was examining a completed wing spar with meticulous attention. "Morning, Mr. Sorensen. Everything's within 2/1000ths of an inch tolerance today. Better than yesterday." "Down." "Martinez here used to inspect luxury cars," Sorensen explained. "Now he makes sure our bombers meet military specs. Each plane has over 1/800 separate inspections before it flies." 2/1000ths, Hoffman repeated, unable to conceal his surprise. This level of precision matched or exceeded what the best German factories could achieve. As the tour continued, the German engineer's skepticism began to mix with growing professional curiosity. The assembly line itself was a marvel of industrial engineering, a complex choreography of thousands of workers and machines moving in synchronized precision. Aircraft took shape before his eyes, flowing down the line in various stages of completion. "We're currently producing one B-24 every 160 minutes. Sorensen noted casually as they watched a nearly complete bomber rolling toward the end of the assembly line. "By next month, we expect that to be down to 100 minutes. "Impossible," Hoffman declared flatly. "The Junkers plant at Dessau requires nearly 3 weeks to complete a single Ju-88 bomber, and they are among our most efficient facilities." "Come back in a month and time it yourself," Sorensen challenged with a good-natured grin. "Better yet, stay and help us improve. Your expertise could be valuable, and it's better than sitting in a POW camp, isn't it?" That evening, in the modest but comfortable quarters provided for him at a nearby military facility, Hoffman began making detailed notes about what he had observed. His analytical mind couldn't help but be engaged by the technical problems Ford was solving. Despite his ideological resistance, the engineer in him was fascinated. Over the following weeks, Hoffman's role evolved from reluctant observer to active participant. Initially maintained as a closely monitored consultant, he found himself drawn into technical discussions with Ford's engineers. American openness and pragmatism, Qualities he had dismissed as naive simplicity proved remarkably effective at solving production challenges. "The issue is the ball turret assembly," explained Helen Davidson, a former mathematics teacher now heading a production engineering team. "We're losing nearly 30 minutes per unit on installation alignment." Hoffman studied the blueprints and the assembly process, his professional instincts overriding his political reservations. "The problem is not the installation sequence, but the pre-assembly. If you reorder these steps and create this jig," he sketched quickly on a notepad, "you could reduce the time by 2/3. Davidson studied his drawing and nodded appreciatively. "That's brilliant, Doctor. Hoffman will implement this tomorrow." Such exchanges became increasingly common. Hoffman found himself drawn into the problem-solving culture that permeated Willow Run. Ideas were judged on their merit rather than the rank or background of the person suggesting them. A junior female engineer might critique a senior manager's approach, and if her solution was better, it would be implemented without hesitation. This egalitarianism was entirely foreign to Hoffman's experience in the hierarchical German aviation industry, where authority and expertise were inextricably linked to position and credentials. Here, results alone determined value. As July turned to August, Hoffman witnessed the production rate increase from 6 bombers per day to 8, then 10. Each B-24 contained more aluminum than 13 500 kitchen pots, enough wiring to power 125 homes, and more than 250,000 rivets. Yet they were emerging from the end of the assembly line with clockwork regularity. Major Donovan visited periodically to evaluate Hoffman's cooperation and gauge his psychological state. During one such visit, he found the German engineer hunched over production charts with Charles Sorensen. "If we reconfigure this section," Hoffman was saying animatedly, "we could potentially increase daily output by another 15%. Dr. Hoffman appears to be adapting well to his circumstances," Donovan observed dryly to Sorensen after pulling him aside. "He's brilliant," Sorensen admitted. "Some of his suggestions have solved problems we've been wrestling with for months. It's almost like he's forgotten whose side he's on." Indeed, Hoffman's professional engagement was increasingly overwhelming his national loyalty. The technical challenges of mass-producing complex aircraft had become an intellectual puzzle that consumed him, transcending political boundaries. This internal conflict came to a head in September 1942, when Hoffman was introduced to a newly arrived group of German POWs, Luftwaffe pilots and crew members who would be shown through the facility as part of an American psychological operation. The plan was simple: demonstrate to these frontline German personnel the overwhelming industrial might they were facing. Among the prisoners was Hauptmann Kurt Weber, a Luftwaffe bomber pilot who had been shot down over England. His face bore the proud, defiant expression common to newly captured officers still fully committed to the Nazi cause. "Dr. Hoffman? Is it really you?" Weber exclaimed upon recognizing the famous engineer. "They told us you had been killed in action. Your work on the Bf-109 stabilizer saved my life during training." Hoffman felt a momentary surge of national pride, followed immediately by a wave of confusion about his current circumstances. "Hauptmann Weber, yes I am. Working here now." "Working? For the Americans?" Weber's expression shifted from surprise to suspicion. Under duress, of course. Before Hoffman could formulate a response that wouldn't betray the complexity of his situation, they were interrupted by the deafening sound of a shift-change whistle. Thousands of workers began streaming toward the plant entrances for the afternoon shift, a human river flowing into the massive factory. "My God," Weber murmured, watching the endless procession. "How many people work in this one facility?" "Currently 331 workers," Hoffman replied automatically. 3 shifts producing around the clock." "And this is just one factory?" another German POW asked incredulously. We were told American industry was soft, unprepared for serious warfare. Hoffman found himself at a crossroads. Professional honesty warred with patriotic loyalty. They are producing one 4-engine bomber every hour and 40 minutes, he finally said, his voice clinical and detached. By next month, it will be one per hour. The factory is still increasing efficiency. The group of Luftwaffe POWs fell into stunned silence as they were led into the main assembly building. The scale of production was simply beyond their comprehension, a physical manifestation of industrial capacity that made German propaganda claims of eventual victory seem suddenly, painfully absurd. How can we possibly win against this? One young navigator whispered, not to anyone in particular. It was a question Hoffman himself had been avoiding for weeks. The mathematical reality was becoming inescapable. For every German fighter plane, the Americans could produce 3. For every German bomber, 10 American equivalents could be built in the same time frame. And this was just one factory among dozens across the United States, a country whose homeland remained untouched by bombing, whose resources were virtually limitless. That evening, Hoffman sat alone in his quarters, confronting the implications of what he now knew. The technical superiority of individual German aircraft, something he had taken professional pride in, was becoming strategically irrelevant in the face of American mass production. Quality, no matter how refined, had numerical limits that quantity could eventually overwhelm. As autumn turned to winter, Hoffman's transformation accelerated. His technical suggestions became more fundamental, aimed at core production processes rather than incremental improvements. He was no longer simply solving problems presented to him, but actively identifying bottlenecks and proposing solutions. We should reorganize the entire sub-assembly sequence, he explained to Sorensen and a group of production engineers one December morning. The current system follows traditional aircraft construction logic. But if we adopt more automotive-style modularity here, and here, he indicated several sections on the factory layout, we could potentially achieve one bomber every 55 minutes. The room fell silent as the implications sank in. One bomber every 55 minutes meant more than 25 heavy bombers per day from this single plant, more than the entire monthly output of comparable German factories. Can you draw up the detailed plans for this reorganization? Sorensen asked, his expression serious. Hoffman hesitated only briefly before nodding. He had crossed a line, from passive cooperation to active contribution to the American war effort, yet he couldn't deny the professional satisfaction he felt. Here, his expertise was being fully utilized in ways that the rigid German system had never allowed. The redesign was implemented over the Christmas period of 1942, requiring intensive effort from the entire Willow Run team. When production resumed in January 1943, the results exceeded even Hoffman's calculations. The 1-hour target was achieved by February. During this period, Hoffman's status evolved as well. While still technically a prisoner, he was granted increasing freedom within the facility and surrounding area. His quarters were moved to a private apartment near the plant, and he was given access to technical journals, engineering resources, and even recreational facilities. More significant than these physical changes was his psychological transformation. The engineer who had arrived convinced of German technical superiority had been confronted with undeniable evidence to the contrary, not in the narrow measure of individual machine performance, but in the broader, more decisive realm of industrial capacity and production philosophy. On March 15, 1943, Willow Run celebrated the completion of its one Zereth B-24 Liberator bomber. The milestone aircraft was rolled out with ceremonial fanfare, complete with factory workers signing their names on the fuselage and a small orchestra playing patriotic tunes. As the gleaming bomber was towed onto the airfield, Hoffman stood alongside Sorensen, watching with complex emotions. The Germans' expertise had contributed significantly to reaching this milestone ahead of schedule. The plane represented both his professional achievement and the inevitable defeat of his homeland. 1,000 bombers, he murmured, almost to himself. In Germany, this would represent nearly 3 years of production. Here, just 9 months. Sorensen nodded thoughtfully. And we're not done improving. By summer, we'll hit bomber number 200. By year end, probably 500. The mathematical progression was inexorable. Each bomber carried 10 men and 4 tons of bombs. Each could strike targets over 200 miles away. Each represented industrial capacity that Germany could not match, let alone exceed. Later that day, Hoffman was surprised to be invited to a meeting with several high-ranking military officers, including General Henry Hap Arnold, commander of the U.S. Army Air Forces, who was visiting Willow Run for the milestone celebration. "Dr. Hoffman," General Arnold addressed him directly, "I've been briefed on your contributions here. Your expertise has helped save American lives by getting more aircraft to our boys faster." Hoffman wasn't sure how to respond to this acknowledgement from an enemy general. "I am an engineer, sir." The technical problems were interesting. Arnold smiled slightly. "That's what Sorensen said about you, that you couldn't resist a good engineering challenge, regardless of the flag on the factory roof." The general slid a folder across the table. "We're establishing a new analysis group to study German aircraft recovered from combat zones. Your technical knowledge would be invaluable. This would be a formal position, with appropriate compensation and a change in your status from prisoner to consultant." Hoffman stared at the folder, understanding fully what it represented. This wasn't merely a job offer. It was an invitation to officially change sides. "May I ask why you would trust me with such sensitive work?" he questioned. "Because you're an engineer first and a German second," Arnold replied bluntly. "Because you understand what these production numbers mean for the outcome of the war. And because I think you've seen enough of America to know we're not the decadent, soft society your propaganda claimed." That night, Hoffman lay awake considering his options. The rational, calculating part of his mind, the engineer's mindset that had defined his life, had already accepted the inevitability of German defeat. The production disparities were simply too great to overcome, regardless of the technical refinements the Reich might achieve. By morning, his decision was made. He would accept the position and formally work for the American war effort. The choice was partially pragmatic self-preservation, but also a professional's recognition of superior methods. The American system, with its emphasis on standardization, interchangeable parts, and production efficiency, represented the future of industrial manufacturing. Germany's craft tradition, for all its precision and quality, was simply outmatched in modern warfare's arithmetic. In April 1943, Hoffman was transferred to Wright Field in Dayton, Ohio, where he joined a team analyzing captured German aircraft. His insights proved invaluable in understanding the Luftwaffe's technical capabilities and limitations. More significantly, he helped American engineers incorporate the best elements of German design philosophy while maintaining mass production practicality. As the war progressed, Hoffman occasionally encountered other German technical personnel who had been captured or had defected. Many underwent transformations similar to his own when confronted with the scale of American industrial might. "It's not just the numbers," he explained to Dr. Werner Schmidt, a metallurgist who had recently arrived from a POW camp. "It's the philosophy behind them. In Germany, we designed aircraft for perfection, then struggled to produce them. Here, they design for production from the beginning. The entire engineering approach assumes mass manufacturing." Schmidt shook his head in disbelief. "At Messerschmitt, We were still hand-fitting major components when I left. Each Me-262 jet was essentially a custom machine. While here, they're building B-29 superfortresses, aircraft far more complex than anything we have, at a rate of 7 per day, Hoffman replied. The contest was never about which side could build the better aircraft. It was about which side could build thousands of good-enough aircraft. By early 1945, as Allied bombers produced at Willow Run, and dozens of other American factories darkened the skies over Germany day and night, the consequences of this production disparity became impossible to ignore. The Reich, that had boasted of thousand-year dominance, was being systematically dismantled by the industrial output of the nations it had dismissed as inferior. In late April 1945, with Berlin surrounded and the Nazi regime collapsing, Hoffman received news that his former colleagues at Messerschmitt had been captured by advancing American forces. Among them was Dr. Karl Müller, once his department head and mentor. Their reunion at Wright Field was awkward initially, filled with unspoken accusations of betrayal on both sides. "So it's true," Müller said after they had exchanged formal greetings. "You've been working for them all this time." "I've been working for rational science and engineering," Hoffman replied evenly. "The outcome of the war was determined by production capacity, not technical elegance. I simply acknowledge reality sooner than most." Müller's face hardened, then slowly relaxed into resignation. "They're taking us to see Ford's bomber plant tomorrow. Is it really as impressive as the intelligence reports suggested?" "More so," Hoffman answered. "Willow Run is producing one B-24 every 63 minutes now. They've actually slowed production because they're transitioning to newer models. Total output to date is over 8,500 bombers from that single plant." Müller closed his eyes, absorbing the significance. All those years we spent perfecting the smallest details, believing technical superiority would ensure victory. While they were building airfields faster than we could bomb them, and factories faster than we could destroy them, Hoffman finished. "The mathematics was always against us, Karl. We just couldn't see it through our pride in German engineering." No. After Germany's surrender in May 1945, Hoffman was offered American citizenship and a position with a major aircraft manufacturer. Unlike many of his technical compatriots who were recruited under Operation Paperclip for their specialized knowledge, Hoffman's value lay in his unique understanding of both German precision engineering and American mass production techniques. In the post-war years, he became an advocate for combining these approaches, maintaining quality standards while embracing efficiency and standardization. His influence helped shape the American aerospace industry during its explosive growth in the 1950s and beyond. Occasionally, Hoffman would visit Willow Run, which had transitioned back to automobile production after the war. The massive building that had once housed the most productive aircraft assembly line in history now produced civilian cars for America's booming post-war economy. During one such visit in 1962, nearly 20 years after he had first seen the plant, Hoffman stood in the parking lot with Charles Sorensen, both men now retired but still consulting occasionally. "It's hard to believe now," Hoffman remarked, looking at the peaceful facility, "but what happened in that building changed the course of history, and my understanding of engineering's true purpose." Sorensen nodded. "Not bad for a bunch of crude Americans with no appreciation for craftsmanship, eh?" Hoffman chuckled at the gentle ribbing about his initial attitude. "The greatest engineering achievement isn't creating a perfect single example. It's creating a system that produces thousands of highly functional examples when they're needed most. That's the lesson I learned here." As they turned to leave, Hoffman took a final glance at the enormous structure. The building that had once produced a bomber every hour had not just manufactured aircraft, It had manufactured victory, one aluminum fuselage at a time, in a relentless industrial rhythm that had overwhelmed all opposition. In his later years, when asked about his wartime experience, Hoffman would often remark that the most powerful weapon of World War II wasn't any particular aircraft, tank, or bomb. It was the American production line, an unassuming but unstoppable force that had transformed raw materials into military might with unprecedented efficiency. The greatest German engineering error of the war, he would explain to university students, wasn't technical, it was philosophical. We believed that quality would triumph over quantity. What we failed to understand was that America had found a way to have both. Friedrich Hoffmann passed away in 1976, having spent more years as an American citizen than he had lived in Germany. His personal journey from scoffing German perfectionist to advocate for American production methods mirrored the larger technological transformation that the war had accelerated. The future belonged not to artisanal craftsmanship, but to standardized precision, not to the workshop, but to the assembly line. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.